Before AWS, before Google Cloud, there was an operating system that basically invented the cloud decades too early. Seriously, while the rest of the world was arguing about floppy disks, a small group of computer scientists built a system where programs could run on remote machines, files lived across a network, and computing power wasn't tied to your desk. Today, we're digging into the obscure, the brilliant, and the criminally underrated OS that quietly predicted our digital future.
Behind every moment lies a scientific wonder. I'm Kale, and welcome to SciCurios, where curiosity meets science.
Our story begins with Multics, a time-sharing operating system from MIT's Project Mac. Researchers envisioned a world where users accessed computing resources remotely, an idea fully documented in MIT's Multics papers and Organics, the Multics system. Multics allowed multiple users to log in at once, share file systems, and run programs stored on remote hardware. This was the service model before Silicon Valley even had a name for it. This pioneering system, developed with significant ARPA funding, laid the groundwork for concepts like hierarchical file systems and multi-level security, which are fundamental to modern computing environments. Meanwhile, ARPANET experiments, described in Liner et al.'s history of the internet, proved that computers could talk to each other across long distances. Researchers realized, hey, maybe one machine doesn't need to do all the work. The ARPANET, starting with just 2 nodes in 1969, quickly grew to dozens, demonstrating the viability of packet-switched networks and distributed communication. This ability for machines to communicate and share resources remotely was a crucial step towards the interconnected world we know today, far beyond simple point-to-point connections. But our forgotten OS takes its true form at Xerox PARC. Their networked systems let apps, files, and printers exist anywhere on the network. Users didn't care where the computation happened, as long as it worked. Xerox PARC's Alto workstation, with its bitmap display and mouse, combined with Ethernet, created a truly integrated computing experience where resources were seamlessly shared. This vision of a network as a single address space, where applications and data were location independent, was a direct precursor to modern distributed systems. Then the idea evolved further with Amoeba, a distributed OS by Andrew S. Tannenbaum. Amoeba used a microkernel design and made a whole network of computers look like a single powerful machine, just like modern cloud clusters. Amoeba's processor pools allowed tasks to be transparently migrated to available CPUs, optimizing resource utilization and providing fault tolerance, much like today's container orchestration. Its distributed file service, known as bullet servers, offered high performance and reliability, managing large amounts of data across the network efficiently. This forgotten OS, built on top of research like Multics, PARC systems, and Amoeba, introduced remote execution, distributed file access, and transparent resource sharing long before AWS launched in 2006. It was a culmination of decades of research into making computing resources accessible and scalable, anticipating the very foundations of modern cloud infrastructure. In other words, it predicted cloud computing, decades early. The core principles documented in Armbrust et al.'s view of cloud computing, elastic resources, shared infrastructure, distributed processing, were already in motion. The vision of on-demand computing, where resources could scale up or down based on need, was clearly articulated and partially implemented in these early systems. If only someone back then trademarked the cloud, they'd be not watching this video on YouTube, probably on their private island. This early foresight, though not immediately commercialized, highlights the incredible intellectual leaps made by these pioneers. So why was it forgotten? Timing. The world didn't have widespread networking, affordable hardware, or the commercial need for cloud services yet. Brilliant tech, wrong century. The prohibitive cost of hardware and the lack of ubiquitous high-speed internet meant these advanced concepts remained largely in academic and research settings. It wasn't until the early 2000s, with the rise of the internet and cheaper computing power, that the commercial viability of cloud computing truly emerged. But make no mistake, today's cloud stands on the shoulders of these early pioneers. Their work shaped the digital world we rely on every day. Their foundational research in distributed systems, remote access, and resource sharing provided the intellectual bedrock for every major cloud provider. Which early tech do you think deserves more credit? Drop it in the comments. We might feature it next.
Science is everywhere if you just know where to look. Thanks for watching SciCurious. Until next time.